the red light for recording is on. And when you join the session, like who's done this? Mark has joined. You're agreeing to being recorded if you happen to chat or anything like that. Obviously, I'm recording, and so if you participate, you're kind of, nothing bad happens, and if something bad happens, I'll delete the recording, and it's like it never happened. So as I said, I will post these as they become available. There's an external source that has to sort of prep them in order for me to have access to them and then give you access to the recordings. Sometimes that takes a little while, so as soon as they are available, I'll be putting them on that page that has last year's recordings. I'll get rid of last year's, or I'll put them on a separate page. So this year's will be available nice and clean and easy to get to. So today what we're going to do is we're going to start changing your brains with a discussion of binary. And as I mentioned, the whole subnetting chapter comes in chapter 8, I think. And in order to build up your tolerance for binary and for subnetting, we're going to start today and go through some little exercises and sort of introduce you to the concept and the topic. Now these exercises I've made available to you if you want to download them and use them. They are on the home page for the class. Scroll down and the class links brings you to the page for getting into the online session. And as a reminder, the password or the PIN that you type in for the online session is here as well. So Sam's Binary Games is what I'm using from Sam Bone at City College in San Francisco. It's simply a zip file with a bunch of PowerPoint slides and a little discussion about why we're doing it this way. And so Sam has, in all of our experiences, we found that trying to teach you subnetting in one chapter in the middle of this class and then moving on is insane. So we found that by doing a little and building up, and you have a lot more success at understanding the topics. So that's how we're going to go with this. So these PowerPoint slides are not a part of the official course. They're not going to be in the exams for the chapter. They're not a part of the final. It's just an additional way of material and content that I'm presenting that we should hopefully get you through the topics. So, yes. Who's they?
Binary games on the page, and they said you can go there and you can look at the binary games. It shows game one, nibbles, and hard points. These are just.
That's Sam's. This is Sam's website. Is that what you're talking about here? This is not this doesn't count. Well, it is part of the class. It's not a part of your grade. Okay. So good. So the link brings you here to Sam's webpage. So Sam is everything that he does. He just puts up on his website, which is notice https://samsclass.info. You can go there. All kinds of stuff that's going to overwhelm you is available. So that's the link to where the stuff I'm using is located. He uses it in his classes. Good morning. And you get points for doing that stuff in his class. Okay? So if you want to access it, you can refer back to it there. Okay? But so good. Thanks again for hopefully clarifying things. So this is, see it all okay? Binary lesson number 1, nibbles. So how many of you can count to 10? hopefully, and we do it because of our, so this is going to be a little bit basic, but I'm going to do this review because there's a system that we use that you're unaware of, probably. So we count to 10 most likely because we've got 10 digits, and that's sort of the way we were born and grew up with and throughout history. But those 10 things that we count up to start at 0. So we have 10 units to go from 0 to 9. So let that sink in. So we count from 0 to 9 using 10 single digits. And there they are, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are our counting numbers. We use base 10 with those 10 digits. Duh. This isn't hard. This is like you don't have to. There's no trick here. The trick comes in with understanding, for example, the number 147. We write 147. We know that it means 147, but we have to break it down into how many hundreds are there? There's 100. How many tens are there? I've got 4 tens, and how many ones are there? So I have 100. I have 100 plus 4 tens plus 7 ones. Now we also break that down into what's called exponential notation. Exponents? No, maybe, yes. So one way of writing exponents is in this format where we have 1 times 10, and that little caret is the one way, a symbol that we use to indicate an exponent. Another way, I'll write on the board, well, I can't write over there. So would be 10 squared, or 10 with a little 2 and up above. So everybody familiar with that? We've seen these exponents. So 10 to the 7th is 10 with 7 zeros after it. It's a 1 with 7 zeros after it. 10 squared is a 1 with 2 zeros after it. Not hard? But this process, we're going to use this process for other counting systems. So that's why we're breaking it down with something base 10. So if I have 326, how many hundreds do I have? So how would I write that using this notation? 3 times 10 to the power of 2. You start early in the morning, and it's like we do the easy stuff first. Okay, so far so good? So this is actually how we've always been counting. And if you go back in 3rd grade or someplace like that, or 5th grade maybe, this basic algebra is discussed in there. And then we go on and do other things with algebra. So this is our base 10 kind of normal counting procedure. Another way of looking at it, we have the hundreds place, the tens place, and the ones place, or columns. Right? So I have the ones columns. So how many ones do I have? How many tens do I have? How many hundreds do I have? How many thousands? How many 10,000s? Right? So you get the idea. Each one of these numbers is in a column that represents a power of 10. So that's how we do base 10. These are all columns with powers of 10. Base 2. If base 10 has 10 counting units, how many counting units will base 2 have? Very good. 2. And those numbers are 0 and 1. You go, geez, I can't do a whole lot with that, can I? Well, what happens is we end up having, in order to get like 156, we have 3 columns. We can get to 156 with base 2, but we're going to need a whole bunch more columns. The number 11 in decimal, well, let's do binary. Sorry. So 1, 1 in binary translates into decimal over on the right is our ones column, and then we have a 2 column, and then we have a 4 column, and then we have an 8 column, and then a 16 column because of the powers of 2. That would mean that you have to bring brownies to the class, or granola bars, since it's the morning, for everyone. No. Coffee? Remember when we had base 10, the furthest right column was the ones column? Notice this thing, the ones place is 10 to the 0 power. Well, 10 to the 0, what the heck? Is that a 0? In exponents, any number raised to the 0 power is 1. A billion to the 0 is y is beyond the scope of the class. You're going to hear that phrase a lot. It's my favorite phrase to use in here. It's beyond the scope of the class. If you ask me a question, oh, by the way, you may not ask questions that start with the word y, and I will oftentimes say it's beyond the scope of the class in order to get through stuff. Sometimes I'll explain it, sometimes I don't know it, and in order to hide the fact that I don't know the answer, no, I know everything, so that's not really true. But seriously, sometimes a question is like covered in later course, and if I feel that answering it now would just be confusing, I'll say it's BSO, whatever that is, beyond the scope of the class. The why questions are sometimes, why does Cisco do this? And I honestly don't understand all those Cisco engineers' thought processes down in San Jose. So that's why you can't ask why. All right, so y, any number raised to the 0 is a 1, is beyond the scope of the class. I can show you the math for it, but we're just go on faith for now. So when we go to base 2, our number 11, or 1, 1, the number on the far right is in the ones column because it's 2 to the 0. Remember with base 10, everything was in 10 to the 0, 10 to the 1, 10 to the 2, in order to get the ones, the tens, and the hundreds columns. With base 2, we have 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, and so forth. 2 to the 0 gives us the ones column. So the digit in the far right is in the ones column. So how many ones do I have? There's 1, 1. Now the second column is 2 to the first power. Now 10 to the first power is 10. So if any number raised to the 0 is 1, any number raised to 1 is itself. So 10 times 1 is 10. 2 times 1 is 2. My brain stopped. So the first one is in the ones column. The second one in this number 1, 1 is in the twos column. So how many twos do I have? I have 1, 2. And how many ones do I have? 1, 1. So to convert from binary to decimal, I simply count the number of ones and zeros that I have for the appropriate column translate it to decimal and add them up. So let that sink in for a minute. You're creating new synapses and things in your brain, and your brain is being rewired at the moment. Please wait for the download to complete, and then we will continue. Okay. So there we are. There's our zeros column, our twos column, and our fours column, because 2 to the second, or 2 squared, is 2 times 2, audience response, 4. 2 to the third is 2 times 2 times 2 is 8. 2 to the fourth, 2 times, we're just doubling. You are going to know the numbers 0, 1, 2, 4, 8, 16, 32, 64, 128 really well. Those are magic numbers. Those are numbers we're going to use over and over again, and we're going to add them up. We're going to add 128 and 32. We're going to get 64 and 16. So all those different combinations are going to give us numbers that are going to be very important to us, especially when we get to subnetting. So 0, 1, 2, 4, 8, 16, 32, 64, and 128, that string of numbers are the numbers 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and 2 to the 7. So how many numbers was that altogether? If I go from 2 to the 0 up to 2 to the 7, that's 8 numbers. Right? From 0 to 7 gives me 8 numbers. Right? So if we count to 7 in base 10, y'all pretty good at that, I bet. 0, 1, 2, 3, 4, 5, 6, 7. There's our 8 numbers. So look at how we count to 7 in base 2. How many digits does it take to get up to 7 using base 2? Well, there's 3 digits there. So I need some, well, in this case, I can't get there with just ones. I can go from 0 to 1 in the first column. That's as far as I can go. In the second column, I've got 0 or 2. In the second, all I get are 1s and 0s in these columns, right? So with 1 digit, I can count from 0 to 1. That's 2 numbers. That's base 2. 1 column, 2 digits, 2 numbers. If I want to go beyond 2 numbers, I need another column. It's just like if I need to count to 10, the number 10, I need 2 columns. I can go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How do I get to 10? Only using 1 unit, 1 digit, I can't get there. I need 2 digits to get up to 10. I need 1 10 and 0 1s, right? To get to, anything up from 10 to 99, 2 numbers, right? To get from 100 to 199, or excuse me, 999, how many digits do I need? I need 3 digits. So I can have 9 100s, and I can have 9 10s, and I can have 9 9s. That's as far as I can go. I can't get to 1,000 using only 3 digits. I need another column. I mean, old enough, I'm sure you aren't, to remember cars that had the analog odometers, how they roll over. I'll give you a link for a digital odometer because it's going to help for counting. But just like that, you've got the tenths, right? A tenth of a mile, it rolls over. What happens when you get to the 9? Well, that rolls over and becomes a 0, right? Because you can go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then how do I get beyond that? Well, but next column over, takes 1, now I have 1, 0. And you go, and that tenths goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. and it goes back to 0, but the column over ticks over to a 2. So you see how that goes, right? And we go 0, and you get to 9 in the ones column, and then you get the tenths is going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and now I've got 9, 9, and what happens? Both of those roll over to a 0, and the third column gets a 1. Oh yeah, so it makes sense. We're just going to do the same thing with base 2. Our wheel only has 2 numbers on it. You got a 0 and a 1. The first wheel is a 0, I count to 1, and I got a 1. Now when I roll that wheel over, it turns back to a 0, and the one next to it goes over to a 1. So that's how we're counting in base 2. I have a 0 and a 1. Now I go 0, 1, 1, 0. So how many 2's do I have? I've got a 2 and 0 1's. How many 2's here? I have a 2 and a 1, which gives me a 3. Now over here, this is the 4's column. So I've got 1, 4, 0, 2's, and 0 1's. Down here, there's a 4, 2, 6, 0, 6. See how that works? So I can count 8 units, 0 through 7, with 3 digits. Okay, I want your brains process that for a minute. It's downloading. Yeah, I got that. Happy? You good? That got us to 7. Now if we want to go to 16, from 0 to 15, I'm going to need another digit. So I need some 8's and 4's and 2's and 1's. Because what do you think 8 plus 4 plus 2 plus 1 equals? That's 15. Here's a safety tip. Anytime you have an odd number and you have to convert it to binary, what will the number on the far right be?
1.
Yeah, it's one of those. It's a 0 or a 1. See, you got a 50-50 chance there. It's going to be a 1 because it's odd. And if you add even numbers together, you always get an even number. An even number plus an odd number gives you an odd number. So if we have an odd number, the only odd number in our column is the last one's a 1. Everything else is even, like 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 5086, and so it goes. So if you've got an odd number in decimal, if you convert to binary, you jolly well better make sure there's a 1 at the far right. Safety tip. We're going to give you lots of safety tips to help you pass tests quickly. Because on the tests that we do, and Cisco gives you, we like to fool you. So what you want to do is eliminate everything that's not right away. So anytime you're going to go decimal to binary, if you have an odd number and you've got 5 options, you can throw away any of those options that has a 0 on the far right. So that improves your chances of guessing. I mean, you had a 50-50 chance. You're going to have you've got a 20% chance guessing when you got 1 out of 5. So let's throw away the 2 that have 0s on the end. Now if you're going to take a random guess, you got 3 guesses instead of 5. Okay. 4 bits we call a nibble because mathematicians have a great sense of humor. Because 8 digits is called a byte. And if you don't take a full byte out of something, you're just taking a little nibble. I don't make this stuff up. It's just the way it is. So do you see, I want to make sure you get they're not showing you the powers of 2 here. But are you seeing that? Over on the far right, we have 2 to the 0, and that's my 1's column. Going left, my second column is 2 to the 1, my 2's column. And the third column is my 2 to the second, which is my 4's column. And then 2 to the third is the 8's column. 2 to the third, 2 times 2 times 2. Right? So now when I'm counting with 4 bits, I can get up to 15. Now this is going to come in really handy for the rest of your lives, believe it or not, if you survive the courses. Being able to identify quickly what these 4 bits are, right? Being able to convert from decimal to binary with 4 bits is going to help you solve a lot of problems that we do with IP addresses and subnetting and a lot of conversions. Now all of this stuff that we're doing, this is a little bit of a hazing ritual. So anybody has sororities, fraternities, you've heard about those things, seen the movies. You got to do some crazy stuff in order to get into the club. Okay, the crazy stuff that you have to do to be a networking guy or girl is you have to be able to do subnetting. And you have to understand binary. There are calculators and there are tools that do this for you. But I think, as I mentioned, I had a student, I had a story about the student who could do everything in the course but could never pass the CCNA test because he could not do subnetting with paper and pencil. Took it 3 times. He just couldn't pass it. I mean, he understood the process. He could work with it. He could use subnet calculators and plug the information into the machines and make it work, but he couldn't do it manually. So we'll show you that, like the curriculum is insane, and they have these giant pages of it. I'll show you the shortcuts. And we're going to get from, we do the wormhole, hypertext, whatever, quick answers. And I'll show you why it all works. But if you don't get the why, then you can just go, okay, I know how to do this, and I can get the right answer. And it makes some sense. So part of those shortcuts is understanding and being able to convert these 4 bits into a decimal number. Okay? Good so far? Questions? So, we're going to have some opportunity to prove what you know. Now those of you that are online can take the poll. Those of you that aren't, keep your mouth shut and keep the answer in your head. So on the, let's do this. Not yet. So if you are logged on, you'll notice that there is this A here. That's for a poll. So as the next few slides come up, it's going to be what is 1011 in decimal, and you're going to have choices A, B, C, D, E. You'll choose the answer. It's the poll, and we'll see how you do. It's not graded. Nobody else is going to know your answer. And it's like, rather than having one person blurt out the answer and you going, oh yeah, I get it, I want you all to think about it for a second or 5. You can write it down on a piece of paper, do whatever you want, but I want you all to make sure that you're getting this process. So if you are online, then do the poll. And if I can figure out how to make this work. On my screen. So that you can see the poll. Oh, you're not going to see the poll. Okay. So, what is decimal 7 in binary? So everybody got the way a poll works? And this is for fun, and this is not intended to be threatening or scary. So Paul, you can click on the A that's above the main room, the names, and then choose one in the drop down for the for your selection rather than typing it in the chat. Well, what's the first thing that you can do if you have no clue? It's an odd number, which means, so you've only got two choices here now. That's what's meaning about, okay, let's get rid of the ones that it's not. So it's not A, it's got to be D or E, right? Which one is it? I wonder if it gives us the answer. It doesn't give us the answer. Okay, so 7 would be, you could go backwards. So I have 1, 1. And I have a 2, which gives me 3, plus 4, which gives me 7. So you can just count them up. So E is the correct answer for that one. And I'll clear the poll, and we can do the next one. So now we get to go the other way. Whoops, sorry. So now we're in decimal. Convert that. Sorry, this is binary. Convert it to decimal. So is this 101 or is no? So there has to be some context, and I'll show you how we can tell numbers that are written in binary or hex versus decimal. Well, what are they not? What's 101 not? Not even, so we can throw out the B and the D. And what is it here? The answer would be C, it's 5, because I have 1, 4 and 1, 1. Yes? Are you seeing how that goes? All right, so now go from decimal back to binary. So for all of these, it sometimes helps to make a little chart. So what that looks like, so I've got my little chart up there for my nibble. I have 4 digits. So I've got 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, which gives me a 1's column, a 2's column, a 4's column, and an 8's column. So to convert from binary to decimal, if I have the number 1001, how many 8's do I have? I have a 1. How many 4's? 2's? So I have 8 plus 1 equals 9. If I want to go to the other way, two to the third, 2 to the second, 2 to the 1, 2 to the 0. If I have the number 13, are there any 8's in 13? There's 1 8 in 13, so 8 minus 13 is 5. And you thought the class was going to be hard. Are there any 4's in 5? It's like go fish. Got any 4's? I got 1 go fish. Okay, there's a 4 in 5, so 5 minus 4 is 1. Are there any 2's in 1? So this recording was interrupted. We're back again, and we're on break now, so we'll continue after the break. I was recording. Didn't turn on the microphone. So y'all are going to have to read my lips for that part of the recording. And when I'm off screen, good luck. Sorry, we've just been talking about the NCL. If you missed it, tough. Watch this evening's recording, and I'll try to turn the microphone on and the recording. Thank you. So it's to offset some of the expense, as well as we had a whole bunch of people register and they didn't play. So it's like there's a whole bunch of time wasted. So if you got a little skin in the game, you're more likely to actually do it. If you want to join a team, if you do a team, it's $25 to register a team, but you got 5 people, then it's $5 per person, like that. So that's the quick version of this deal. I have seen, did I say this already? Teams get jobs at, not from this, but when I've been in on-site competitions. There are competitions at universities and things, there are different ones, where the entire team that won has been hired by Boeing. All 5 people, well, 4 out of the 5, because the fifth person was a junior. The seniors, when they graduate, they're at Boeing as a team because of everything that is a part of participating in this are characteristics that employers are looking for. One of them being working well on a team, problem solving, communication. Those are just some of the soft skills that are developed and evident when you participate in these things. Leadership, all of those. And the leadership one is a little tricky because it's not like you don't want to dominate everything and do it yourself. But you're correct. This only takes place in the fall, so there isn't this competition in the spring. So it doesn't come. So it's like, oh, I'll do it in the spring. It's a season. It's like the NFL, right? It's done in the fall, right? So we're done in the fall. To be honest, the reason it's not done in the spring is just too much work. And as I said, most everybody's volunteering for this, and we've got to look back at the last season and find out what worked and what didn't work. Last year, to be perfectly honest, there were a lot of problems. I had this is all monitored electronically in computer. There's algorithms to check different things, and one of the things that's being checked is cheating. And I had, at the end of the season, 2 of my students got a message that's saying that they were being disqualified because they had cheated. And they didn't. They hadn't. I know them, and we talk, and it's like, so anyway, I know the commissioner of this personally, and we talk with him. I work with him, and said, Casey, what's going on? And then we go back and forth. And I said, either there's a, we went through a number of scenarios, and so we worked it out. Apologies were sent, and they fixed the system. There was something wrong with the algorithm that was looking for stuff, and so that was last year. Hopefully, it won't happen this year. But well, you can cheat if you're sitting next to each other and you get an answer and you tell him. It was sharing flags, is what it was. That was kind of one of the things looking for cheating. And I don't know the algorithm. Casey's the only one that knows the algorithm of how it works, because it's a proprietary company that was hired to create the stadium and the whole infrastructure, and so their algorithm or their method of checking for flag sharing and other kinds of cheating is proprietary, and they weren't going to tell anybody, because then if you knew how they checked, you could cheat and you could cheat you get the idea. So we had a long discussion, and then the whole league, all of us were like, I helped to rewrite the rules, and we included stuff about if there's the evidence of cheating or potential cheating, how we go through, if there's a process now. So anyway, it was like the second year. We're trying to figure this stuff out. So give it kind of some slack. We're working on it. It's not intended to condemn you for life. It's not a black, flag or red flag on your transcript or anything like that. But it left a bad taste in a lot of people's mouths, and coaches as well, faculty. And there's a problem with due process and just the accusation, the way it came out. And so we've tweaked all that stuff. And so I'm telling you that kind of like the dirty laundry stuff, so you can know, and you get, it's an education system, and for us educators as well, we're learning, and this is something new. So anyway, kind of cool thing. Play if you want. It's kind of interesting hoot. And if you've never done this before, like some of you are brand new to all of this, do it just for the experience. And see, wow, I really want to get into this field, or, not for me. You'll learn some of that as well. If you get frustrated, it may be because you didn't do the labs or you're missing some of the stuff. Frustration is okay. Like I said, the kids at Cal Poly, they're like, what the heck? It's like, these are computer science majors who supposedly know stuff out of really good school. And they're like, dude, it's like, what's going on? But you learn as you do a few more of them and work in the team, and it's a growth process. So there it is for you. It doesn't sink in with the course sequence for me. My Security Plus class is in the spring. If I do it during the fall, I would probably give extra credit or make this part of the assignment and figure out a way to pay the fee. But as it is now, it's not really quite in sync with any of my classes. But I do use the labs in my classes because they're good. But the competition part, there's no requirement for this class or any of my classes. It's just out there if you want to play. It's kind of cool. I think I'll stop. If you have questions about it later, you can email me or we can chat after class. Item number 2, please. Now, go to your cubby at SRJC and log in. And there's a survey in there. It's called the CTE survey, CTE or something like that, CTEA. I can't show you, I don't have a student account. Maybe I do have a student account. Ooh, watch this. We're going to play. So anybody logged in with CCC Confer and you're on your student portal site? Okay, Brooke. I am going to send you a message and ask, let's see, first off, I'm going to give you application sharing. Okay, on the well, let's walk to your close. I'll look over here. So on the upper right of your left of your screen. Okay, let's click here. This is application sharing. And say OK. And click on the group. Double click on that. Okay, so now you're sharing this. So you're live. Okay, camera's on you. So, pretty cool, huh? So if you're at home, remember I said you can share your machine and you can demo something. You know, if you're not even in class, I can still call on you and you can't hide. So if you would please, click on the CTEA survey, the CTEA survey. So you're all going to do this. I want you all to do this in your cubby. And then I'll turn yours off. You can shut yours off because you don't have to show all of your answers to everybody else. So you can stop the application sharing if you simply click on the little whiteboard up here. So or just click on that little yellow icon on the one on the far. There we go. And now click on the whiteboard. There we go. Well done. Thanks for playing. So fill out that survey. It's anonymous. By you doing this, it's part of funding for the school for what are called CTE, Career Technical Education programs. We get money from the state, from the federal government. So the more students we have in the programs, the more money we get. How do they tell how many students we have in the program? By the survey that you fill out. So that's why we're taking time so that I can get more money to create more classes and get equipment for y'all. Everybody getting there? Everybody looks like doing okay. So it is anonymous. I can see if you have not filled it out. I don't see what you put in, but there's a little checkbox for me that if I wanted to look and punish people who, no, I wouldn't punish you. Got it? You good? Okay, yeah. It's not submitting. Hung up. Well done. Is everybody having a problem? In what class? How hard was Eric's class?
Terrible.
I understand the bar is a little higher here. I mean, and that's nothing against Eric or the class. I'm just saying, you know, clicking on a few radio buttons.
Didn't get the point. It did kind of.
Okay, tell you what. If you can get yours to submit, you get extra credit. Okay, see? I got a little. Damn. So nobody's able to submit?
It could be submitted, it's just not telling you. I think it's submitting.
We have no idea. I'm sorry? Yeah?
At the bottom, there's a little table.
Is it still here on yours?
I can show it to you.
That's okay. So anybody got a little table on them? Oh yeah, here's one. Emma's got one. Yes.
When you hit submit, that disappears.
Yeah.
So the table disappears when you submit?
Yeah. And I think
oh, so it may have submitted. Yeah. When you submit.
Make people submit multiple times so that they won't get more money.
Well, I've done it 3 times already, so.
You get triple extra credit.
You know, when we did Eric in his class, he said there was a problem at first and we had to do it over in order to get the function. I don't remember what the problem was.
It's a computer. I don't know how fast the system responds. So when you submit, that should go away. Right? That's what they're telling me.
That's what happened. And yet, I don't think we get credit for it. Yeah, it happened last semester. Last semester. Had the same problem. I don't remember what been submitted, yeah, I agree. I think that's clear.
It's showing it's completed. for, let's see, Mohammed, Linda, Zach, Ben, Alan, Jesus, Anthony, RJ. So yours is in. Yeah.
Okay. Thank you. This is. Yeah.
Sure, 1,000,000 worthless points.
Yeah. Exactly.
We have monopoly money here. Bitcoins, I'll give it to you. You like the Bitcoins, but it's the bad ones. I don't even know if there are bad ones. So I got the ones on the Dread Pirate Roberts server. Okay, so it is working. Thank you for doing that. And now for something completely different. Our class. Huh. 2 hours. You've been here since 9 o'clock? Yeah. So let's do some learning. How about that? All right, here's the deal. Y'all are kind of lucky. Who cares? In the olden days, the class was different. You didn't get to touch routers or switches until like the last day of the first course. Here we are on the second day of the first course, and boom, we're playing with the routers and switches. The deal is, we're going to get you started configuring them, getting into the device, and doing some basic configuration. Then as we go through the class, we're going to talk about the OSI model, we're going to talk about all this stuff, and we're going to apply it to the routers and the switches. Like, oh, I get it, why we do this thing on the router or the switch, and how it relates to the OSI model. And that's that 7-layer thing that you have to memorize with the application, presentation, session, transport, network, data link, and physical layers. So we will relate those concepts and the things that we do at those layers to the machines, to your PCs and the routers and the switches. It's a pretty practical way of doing stuff. So before we do that, we're going to talk about how Cisco's operating system works, and how you do some basic configurations on these devices. So I got my list of packet tracers and labs and gears and things that we're going to do. We'll see how fast we get through all of that. But my expectation is requirement, demand, insistence is that you all read the chapter 2. No, we'll get, eventually. I am not going to stand up here and read, what was in the chapter back to you. I'm going to kind of highlight some things and go beyond the scope of the class, and maybe give you some extra information about stuff. But I want you to, I know we just started. We did, chapter 1 you didn't have access to. You're supposed to do the quiz for chapter 1. Now we're doing chapter 2, and you got to read chapter 2. And we're going to do the quiz for chapter 2. Remember the whitewater rapids I was telling you about? We're in them. So the quiz is, the first chapter is kind of a gimme. And you can do the quiz, the exam, get 100% eventually. So don't worry too much about that. So I'll be gentle with you on this chapter because I know most of you probably haven't read it, but you got to read it, do the quiz. But I want to focus on the exercises and the activities. So I'm just going to babble for a bit. That hopefully will cover a lot of the stuff in the first part of the chapter. So the idea with Cisco is that they've created an operating system that's, golly gee, it does a whole lot of the same stuff that the operating system on your iPhone, your iPad, your tablet, your computer, your laptop, it's just an operating system. It's called iOS, Internetworking Operating System, capital iOS, because I think Apple uses the little iOS. Theirs is smaller, it's not as important, even though they're more money. So this computer that is up here, for those of you online, do you see a monitor?
Yes.
Do you see a monitor on this? How about a hard drive? So this computer is kind of dumb, basic. It doesn't do a whole lot of stuff. There's no graphical interface card. There's no hard drive that's spinning around getting hot that needs a fan. It has memory and it has flash, flash drive. So flash is instead of the hard drive. There's a board, those Docker boards. There's interfaces that are on here, but rather than just having one NIC to plug into, this does have USB, but they're not used for a whole lot. Other ones do use them. But it's got some different kind of looking interfaces to connect routers together and to connect the routers to switches and to connect the routers to PCs. So this is a computer. And this computer does the stuff up on the screen. That's what it's for. It's for moving stuff around. It does what's called quality of service. And that means my traffic's more important than yours, so I get to go first. That's QoS. It does all of that stuff up there. And we will learn how it's doing those things and how to make it do those things and what we're going to configure as we go through the class. So just think of the thing as a computer. It's an operating system, and here's our operating system for a Linux device. We've got a hardware that everything is on top of. There's the kernel, which is kind of the core of the operating system, stuff that you don't really touch or do anything with. Thank you.
Thank you.
Sometimes when I'm juggling 4 or 5 balls, they drop. Thanks for pointing that out. So here we have a brief diagram about the hardware. We've got the hardware that the thing's running on, the iron, and then we've got the core operating system, the kernel, stuff you don't really do anything with, the touch. We have the shell, that's the interface that allows you to interact with the computer to make it do things. And it's a computer. Most of y'all, and what we're doing here, is using a graphical user interface, or a GUI, a GUI, to control and to access and to manage and manipulate the computer. So some of you have taken a Linux class, and so you're doing the Microsoft, and so Microsoft, well, it's easy, we just click. Underneath all those clicks are a bunch of command lines. There's code underneath there. So if you strip away the GUI, you've just got the code. So Linux is just the code. Doing just the command line is a lot more powerful, it's faster, it's easier after you learn the code. For Cisco, for this class, we are just going to use the command line. There is no GUI. There is a GUI, it's a Java-based thing, and there is one out there, but we're not going to learn the GUI first. We're going to learn the command line, and then we'll show you the GUI later. Because when you know the command line, you'll understand what you are doing with the GUI. The expectation is that when you learn the commands and you're typing them in, you actually know what you're doing, and you are intentionally making modifications to the device in such a way that it's going to do exactly what you want it to do. Pointing and clicking sometimes, oops, I clicked on the wrong link, and what's going to happen? So this is like, you're down in the weeds here. We are just very, very meticulously making exact changes that we want. So that's how, if that helps to think about why we are doing it that way, and we're also doing it that way because Cisco said so. Other vendors, Juniper, they do a command line. They also have a GUI. Everybody has command line and a GUI. And just kind of a macro view, Windows, Microsoft started out, they're just a GUI. And some of you maybe have taken a DOS class or command line for doing some things. So there's always a command line with the Windows GUI. Windows has moved to something called PowerShell, which is like command line on steroids. Very powerful, and they actually require you to use PowerShell for some of the new servers that they've got. The server 2008, I think, required you use PowerShell to do certain things. PowerShell's on Windows 7, 8, and 10. So I'll have a class in PowerShell. So Windows went to the GUI. You know what happened with Linux? No, sorry. The GUI went to the command line. I did it the wrong way. Microsoft, which is a GUI, went to the command line. Linux and Unix, which is a command line, is going to a GUI. So you use both in different instances, and Cisco's the same way. Start off with the command line. We use the GUI for some instances later. And they have different GUIs for different platforms. And we'll leave that alone. What else is going on here? So how do we get into the thing to control it? You can do it remotely. You can do it locally. Locally is much more secure. And there is an interface on the back of this called console. You can pass this around, just don't drop it. It's in words highlighted by a light blue color, baby blue if you like. And that interface, or that port, is an RJ45. There's also RJ11s. You're important. So that's just the size of this interface, this jack. So RJ45s are used for Ethernet connections. This little jack can be used for lots of different things. In this class, the console cable, what color is this? And the words console are highlighted in. Isn't that amazing? This is like Sesame Street, right? We got the blue cable, goes into the blue side. So for those of you online, here's the console cable. So here's the RJ45. And this other side is called an RS-232. And a lot of laptops these days don't have them. The reason that we use them is because this is what was on the shelf when computers were created back in the 80s in the garage of, Mr. Hewlett and Mr. Packard. So that's what's on here to plug into your laptop or your hard drive, your desktop. If you have a computer that does not have one of those RS-232s, then you get one of these. An adapter. This is a serial interface. And what is this thing called, this interface? USB, which stands for Universal Serial Bus. Serial. So it's like Fruit Loops and Captain Crunch. Cereal. They're all cereals. Still need some sleep. Okay. So anyway, this is what you would use if you didn't have one of these. Now, when you connect with the console cable, how close do you have to be to the machine in order to do that? Okay. How close do I have to be to the machine in order to plug this cable in? I got to be touching, right? I have to have physical access. That is a security feature. You lock these machines in a closet, and they're, you've got biometric. Though we don't want to use biometrics. You've got facial recognition, or whatever, before somebody's allowed into your closet where these machines are located. Because if you have physical access, if I can plug this into a router, I own it. I don't care what password you have on there. Okay. We publish, and I will show you how to bypass the password. It's a feature. I'm serious. No, it's not even a backdoor. It's just the way that Cisco sets this stuff. Because if you forget the password, how do you get in? So it's a feature. If you get a machine, and this may happen in the class, so other classes use these machines. So if somebody comes in at night, no, one of y'all in the day, set a password on here, and you don't clear the thing out when you're done and you put it back on the shelf, somebody grabs that machine and you've set some random password on there, how are they going to get into the machine?
Erase the thing, start over.
Erase what?
They reboot it to factory default is what they,
How do you do that without getting access to it?
Like you say, there's a procedure you probably...
You have to have access to it to reboot it to factory default.
Right.
If you reset it to factory default, you just lost all your configurations.
Yeah.
That's a bad thing. And I'll tell you stories about that and guys in jail in San Francisco and so on. The network administrator for the city and county of San Francisco, this is about 4 years ago now, was a control freak. And paranoid, schizophrenic, and I don't know what else. And brilliant. And he was the network administrator, so he had all the passwords and the configuration files for all the routers and switches for the city and county of San Francisco. So a big network, right? Lots of stuff. He also had if you look on the back of that device, you'll see something that an interface near the console that says aux, A-U-X, auxiliary. You could plug a modem into that and remotely access the device and get in as well. There are passwords in all these ways in, so we're going to put a password on the console connection. So you plug in, you got to enter you want to get into it physically, you have to put a password in. Just because you plugged in doesn't mean you're in automatically. We can put a password on that console connection. Well, this gentleman had an episode and locked everything up. And I don't remember the details, but he was the only one with the backups of the configurations. And these configuration files, when you're programming one of these devices, they go on for pages. I mean, it's like get some butcher block paper and go from the wall from here over to there. And there's just a lot of code in these things. So you could reset the machine back to its original factory state, but we call that bricking it. It's like you just lost, all those years of work. So long story short, the guy was in jail. He wouldn't tell anybody the passwords. Nobody could access them, couldn't get in. They couldn't brick it. Cisco engineers, CCIEs, remember those gods of the internet I told you about? Okay, up from San Jose, corporate headquarters is in San Jose. They're nearby. They couldn't get in. They make it so that you can't get in. The only way in, okay, so I was telling you I could bypass the password. There's a setting you can put on those things. God, this is taking a long time. Physical access console session. Remote access, Telnet or SSH. Telnet bad, SSH good. Telnet, clear text, not secure. But that's what you're going to use all class long. Telnet. Just because we're not ready, because I got to get you to the point where we talk about cryptography and how you set up a Telnet and SSH session. Yes. So, for remote purposes, it's Telnet. For local, it's the console session. So that's how you get into the thing. Now, when you connect locally with the console session, it's plugging into your computer. We have to dumb down your computer. They're really powerful, they're really smart, and they know all kinds of things. We need to run a program called a terminal emulation program. Because back in the day, when you accessed the mainframe, you sat at a terminal, and all you could do is type in letters, right? You type in commands and you got back text. Text goes in, text goes out. Terminal, so that was the way you did stuff on a computer. It was a terminal. So now what we have is a terminal emulation program. So now your computer is going to pretend to be a terminal, a dumb terminal. So you will type in letters, words, and you'll get text back. Examples of terminal emulation programs are PuTTY, which is on your computer. Teraterm, which is on your computer. Secure, CRT. So these are just different programs that allow you to enter text and receive text from a device that you've connected to on the console program. Works with the routers, works with the switches, works with all their devices. That's how we get in. You can do the activity on your own. Now, here's where you're going to, I'm not going to play these videos in class for you to watch them. Right? So, the different modes of operation. slightly confusing. There's basically two modes, user and root, or privileged. As soon as you get into the machine, you're in user mode, and then you leave user mode and get into privilege mode. User mode can't do anything except look around. So that's boring. So then you become the privilege mode, user exec. That's where you're like root from Linux, or you're the admin from Windows, user exec. That's where you can do everything. So that's our first mode. And I can live my arms to talk about all this stuff in the privilege mode and what you can do at these different levels, configuring, navigating between modes, what the command structure is. So I can put this up on the screen, but I think you're going to learn by doing it and then going back and reading what you just did. So you've got a prompt switch. So I'm going to switch. I can show some things in this prompt. Learn about the keywords and the arguments and what we're doing here. There's stuff in boldface. You got to read all this stuff, and you're going to forget it. And there's all these shortcuts, and I don't even remember the shortcuts. Help, very important. Help is a question mark. If you forget how to do something, type the question mark. There's one tricky thing with help. If you forget the word, that's a command you want to use, like clock. What's the command for clock? You can start typing CLO question mark. And it will give you a list of all the commands that start with CLO. The clock's the only one. If you type CL question mark, you'll get clear, you'll get clock, and whatever else starts with CL. Okay, it was CL question mark. Now, if you type clock space question mark, see the difference? There's a space in there. You'll get whatever other commands you can do after clock. You're going to do this for a while and it will make sense and you'll forget. Question mark's your friend. On the CCNA, the question mark is available. If you depend on the question mark to do all the commands, you will fail. You don't have 90 minutes of question marking will not get you through. Right? It's a prompt, like, what was it? Oh yeah, it's just like one of those things to sort of help you along a little bit. Because there's a gazillion commands. There's books on this. And in the appendix for this chapter, remember the appendix? So if what do I have? It's up here. So if I go back to the module in chapter 2, here's how I launched chapter 2. Right, you all can do that. If you scroll down a wee bit, you find the appendix for chapter 2. That will open up another page. It looks like that. So here's the appendix. Here's the stuff that used to be in chapter 2 that you had to know and you're going to get tested on. That would say, yeah, you don't need this stuff so much. It's not a part of the CCNA. It's like extra credit. It's more stuff to fill in your brain. One of the things that's in here for chapter 2 is the Cisco command reference. 600-page book in PDF format that you can download. Put it under your pillow at night. By May, you may have it. Nobody does that. The reference is to help you remember what to do and to teach you what to do. If you want to accomplish a task, you look at the command reference and you go, oh yeah, there's something about the map for whatever I want to do with IP addresses. So you go to the command reference, look at the map, and you read about it, and then you go, oh yeah, that's how I do it. That's what the command reference is for. So if you want to find that, here's the instructions on how to get to the command reference, and we'll play with that at some point. So this is what the appendix is for. Here's the Cisco iOS levels and commands that we're doing. Some stuff runs in RAM. What happens when you turn the machine off? What happens to the stuff in RAM when you turn the machine off? Goes away. Random access memory. That's volatile. NVRAM, we didn't know what that stands for? Non-volatile RAM. And then flash, kind of like your flash drives, takes the place of the hard drive. You can configure stuff and store it in NVRAM, so when you shut down and start up, you're back again. And then the operating system is in flash. So this is all in the appendix. Okay, back to your regularly scheduled broadcast. Hotkeys and shortcuts, navigating around quickly. I just hold the arrow key down until I get to where I want. You can't mouse click and move around in the terminal emulation programming window because terminals didn't have mice back in the day. You could only move around. So there's some commands here to how to move quickly to the beginning or to the end of a line, how to jump words instead of holding the arrow key down and letting the cursor move across. So that's what's going on here with all the shortcuts. So, where are we? 246. So let us now have y'all click on Packet Tracer navigating the iOS instructions, or just the Packet Tracer. You don't have to even do the instructions. What happened? Oh, here it is, down at the bottom of my screen. So when I launch Packet Tracer, here's Packet Tracer. Cannot launch the clear terminal. What? So click on OK until that goes away, and then cancel for the user profile. If y'all get to about this point, Packet Tracer's opened up, you've got a switch and a PC. Yes? Anybody not there yet? Click OK, 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 OK. It didn't work. Scroll down. Just scroll this down. So we're hiding. I'm going to close it and start again. No. Did you go back to the class? Go back to the chapter. Yeah, we're in chapter 2. Launch chapter 2. Launch chapter 2. Go to page 2.1.4.6. Just click. Scroll. Yeah. Okay. Happy getting there? Everybody's there? Yes, yes. I need roller skates or something. So the instructions you can open up as a PDF on that other page, but they are also usually hiding. See down here? There's the activity. So the instructions pop up with the Packet Tracer program as well. So 2 windows open with Packet Tracer. Do y'all see that? So down at the bottom, 2 Packet Tracer windows. So there are the instructions as well. Notice with this little window, completion 0 of 20. So pay close attention. This is going to help you win friends and influence people. Some of the labs that I have you do are in Packet Tracer. It will also have this completion percentage of 100. You will be able to determine your percentage simply by looking at that number. I highly recommend that you do 100 out of 100 before turning it in. Then you'll get all the points for that lab. If you aren't up to all of the points, you can click on Check Results and Assessment Items, and it will tell you what you haven't done. Red X's are bad, green checks are good. So anything with a little red X, you want to go back and do again. So if I close this window, I go back to my instructions. So you can move things around, right? I can drag this over here, I can drag that over there, so that you can maybe read both, do the 2 things at the same time. So this is what I was talking about in terms of real estate on your window. Yes? The instructions? Okay, look at the bottom of your screen where it had the packet tracer icon. There's two little icons there, one underneath the other. Here.
Oh, these here. Okay.
Sure. Cool. You got them? So just follow those instructions to go through. It's going to have you drag and drop, connect, put an address. So we'll just walk through this. Click the connections icon, the one that looks like a lightning bolt. Select the blue console cable. That's this one. Click it on the PC. That plugs into the RS-232. Go to the switch. Those are all the Ethernet ports on there. We don't want to plug into that. We want to plug into the console cable. Click the PC. Did that, drag down the end. Establish a terminal session with S1. So I'm going to go to the PC. I'm going to click on it. Cannot launch PC. What? Look into that. So now I've opened up the PC. Notice we have a physical tab. I can turn the PC off by clicking the off button and the on button. Green light comes on and off. On the desktop, I have programs. If I want to establish a console session with the switch, that's the terminal emulation program, I click on that. I'll probably go with the defaults. We'll learn more about this later. I click OK, and now there's my terminal program. I can hit Enter. And at the bottom it says S1 with that caret symbol. That tells me I'm in user mode. If I want to become the privileged user, I type in the command enable. Enable is our command to move from privileged to, or excuse me, from user to privileged mode. So when I type that command, notice the prompt changes from the caret to the pound sign. So that pound sign is the clue that tells you now at privileged mode. And from here, I can do all things. Okay, okay, okay. Just ignore it. Click on OK. Same as last time. Okay. That was the same error you saw last time. So what we're doing is virtually the same thing that we would be doing with this. This is the switch. And plugging in there. And the other side into the back of the PC. And you just did that with the virtual dragging and dropping. Now, I'll tell you now, and I'll tell you frequently throughout the class, there are no jobs doing packet tracer. You will not, as an expert at packet tracer, be able to get a job. You actually have to know how to work on these things. You can't drag and drop the cable in the real world and plug it into the right port here. So practice in class. And as I said, screw up in class and don't be embarrassed. But it's okay, because you're going to go, oh man, I did it again, and you'll learn. Because there's like, on the router, there's 4 ports you can plug this thing into. Well, look on this little box. There's 10 ports you can plug into here. One of them is light blue, so again, we have a clue. On the router, it's relatively easy. Oops, I plugged into the one next door, or the one below. Right, remember, I passed it around. There's 4 RJ45 female connectors on here. 2 are Ethernet, or fast Ethernet. One's the aux port and the other's the console port. The only one we want to use for connection to the computer is this. This is not Ethernet, right? This is not 100 megabits per second. This is a console connection. It's sending 1 bit at a time this way and 1 bit back that way. You can't go very far with this. You can only send text back and forth on this. That's all it's for. Okay? So you just did in the virtual world in Packet Tracer what I just did here. You can plug it into the computer, launch PuTTY or TerraTerm, and it would look just like that. Now if we look at real-time. Oh, back to the instructions. You notice that it says 20 of 20. So all I had to do there was drag and drop, click it to the right place, and now I've got the 20 out of 20. And if I look at check results and then assessment items, my red X's have turned to green checks, and I'm happy. So that's pretty straightforward here, but that process that we just went through to make sure you had all the points, how to check for what you got right, that's what I want you to get out of this. Because there'll be a lot of items as we go through the class for the labs that you do. So if you don't have all the points, then you go, oh, I did that wrong. IP address on the serial 1 interface is wrong. You can go back to the serial interface, check the IP address, and carry on. So it's a nice way to help check your work. Now, some of the exercises don't have this check assessment, because in the real world, in life, you don't get like a cheat sheet.
You get a grade on it.
Well, you don't get a grade, but much less if something's not right, there's nobody there to tell you. It can't pull up there's no app to tell you that you put the wrong address or subnet mask someplace. You got to go in and figure it out for yourself. So that's why, again, there's no jobs for Packet Tracer, because this is not real. It's just a tool to use instead of the real gear. It's quite good, and to be perfectly honest, it's used mostly at colleges and schools around the world where they don't have equipment, where the students don't have access to the physical gear, because it's relatively expensive. And as I said, this academy, Cisco Academy, it's in 150 countries. There's 1 million students, so it's all over the place. And some schools around the world just, they don't have it. You're really darn lucky to be here. I've got a lot of gear, and the school supports this, so we've got a lot of gear to play with. We've got this remote deal. So I don't want you to get too addicted to Packet Tracer, because there's a certain point where you'll see in the course syllabus, there's a picture of Packet Tracer with a red circle and line through it. It means no more Packet Tracer. So you will have to get weaned off of it and learn how to use the real stuff. No, don't take my Packet Tracer away. Yeah, it will happen. So it's really quite good. It's a good program. It does almost all the commands that you'll need for this class. It does very little of what we do in the CCNA security, and as soon as you move beyond that, you're kind of like, not so good. But it is quite good for the platforms that it manages, and it does. Okay. So you just did an exercise. Well done. The next one, this can go away. I'm not going to save it. Bye-bye. Back to...
Chapter 1 didn't have a lot.
Not that I know of. So this one is doing it with the real gear, like I just did. I don't want to do that one yet. Yes? What a wimp. I'm sorry. Sorry. I apologize for having said that. So let's take a break. This would be an ideal time to take a break. And then we'll continue. Thanks. I'm sorry. That was so inappropriate of me to say that. I apologize. And the recording. Okay, time to do stuff. I'm not going to go over this. You're going to create a device. You're going to create names for the devices. Okay, we don't use names like Gandalf or Thor. They're going to be names that actually indicate where the device is or how it fits into your organization. You can read all that stuff. So some consistent, rational approach to naming your devices in an organization. That's what you want to do. If you're at home, you can do whatever you want. Configure a host name. So notice, we're in the pound sign. How did we get to the pound sign? Enable. So then we say configure terminal. You can type config space T and hit enter. Lots of shortcuts. So instead of typing configure space terminal, which is what you have to do on the CCNA, and only on the CCNA, but in the rest of the life, you can type config, for configure, so it takes shortcuts, config space T, because there's nothing else to configure that starts with a T except for the terminal. You can configure from memory, from the terminal, and something else I forget. If you type configure space question mark, you'll see what you can configure from. Almost everything we do is going to be configuring from the terminal. Config space T. Now notice how the prompt changed. Where once it said switch pound to indicate we are in the privileged mode, now it's switch paren config pound. That tells us we're in the configuration mode. We're actually in what's called global configuration. And there's a lot of levels, and you have to be and each level has certain commands. The global configuration is to do configurations on that affects the whole machine, like the name. If you want to put an IP address on an interface, you have to go to the interface mode. Global mode doesn't allow you to put IP addresses in because on a router, IP addresses are not global for the whole machine. IP addresses go on one interface at a time. So there's layers, and you move between the layers, and you'll kind of get that as we go. There's a diagram in here that shows you all the layers. Just don't let it overwhelm you. We're at this for a year. You're going to get asked, what level do you do this? What level do you do that? It's your second day in class. Don't stress it too much. You'll figure it out as we go. So at global config, we can configure a host name. And now notice, so we say host name space, and it's all one word. And there's no spaces here. Dashes, underscores. Once I hit enter, instead of switch, it now says the name of the host. So switch is the generic name of the switches before they're configured. Or say router if you're on a router. As soon as you put the host name in, boom, you see the host name of the device you're configuring. That's very helpful because if you've got a lot of machines and you're jumping around between them, this is how you keep track of what machine you're on, by the name. So that's configuring a host name. Now, so what's going to happen is there's going to be some activities that pop up, but I'm just going to talk about this stuff for a few minutes, and then I'm going to turn you loose on the last lab. And the last lab will have you doing all of these things. So host name. Now let's secure the device. How do you get into the device? A couple ways. What's the blue cable? Console port. We can put a password on the console port. We didn't do this yet, but other ways are to get in remotely. And what were those programs we used or those protocols we used to get in remotely? Telnet, and SSH. Now, Telnet and SSH get in, you have to put an IP address in your SSH session. So you want to get to an address. So the machine obviously has to have an address before you can get to the address, right? So we will put addresses on the machine. Telnet and SSH go across the VTY line. It's the virtual telephony line. The VTY goes back to the old telephone era days. I'm giving you a little more explanation. So when we put a password for Telnet or SSH, there's nothing physical we can plug into. With the console port, we can go to the console port and put a password on the console port. There it is, it's physical. For Telnet and SSH, we're going to go to an address. Now the routers may have multiple, they will have many IP addresses on them, one or more for each interface. And you can Telnet or SSH into any one of those. So if the router's got 12 IP addresses on it, where do we put the password for getting into the router via Telnet? We put it on what are called the VTY lines. On these routers, there are actually 16 VTY sessions that are available, 0 through 15. So we will put a password on all of those at once. What that means is 16 different people can be telnetted into the router at the same time. That's how they're built. So when we put a password to secure the router, we put them on the console port and we put them on the VTY lines. Those are our ways into the router. We're either physically getting into the router or we are remotely getting into the router. If it's remote, it's Telnet or SSH. We're ignoring the aux port for now. The aux port, you could hang a modem off of that, but we're just going to ignore that. 2 ways into the router, physical or remote. Passwords on both of your ways in, right? We want to lock the door. We don't want just anybody to get in. So we put a password on the console session. We put a password on the VTY lines, which means anybody that gets in through any remote system has to use a password before they can get into the machine. Have I said that enough? Now, we are also going to put a password on the enable command. Do you ever do that on your computers? Do you have a username for your machines? Does it have a password? Do you have an administrator account on your machines? Does it have a password? So the administrator account, the command is enable. So we are going to put a password that you have to enter before the enable command is executed and move you to the privileged mode. Does that make sense? It's like putting a password on the administrator account. So those are the 3 passwords that we're going to put on this thing to secure the device. So secure the privileged exec mode, that's the enable command. We're going to put a password on the console line and for remote access. And we're going to, this one here, it's a little confusing. If we want to see our configuration file, we say show and then the command to see the configuration file. It's the one that's in RAM that's working is called the running configuration file. So it's running on the machine. So if we want to see what's running on the machine, we say show run or show running -config. Show run. When we type show run, everything appears and it's in clear text, including some of the passwords. Some. If we want to obscure those passwords, we can do that with this enable all passwords command. I'll show you that one. Finally, in our list of things to do to secure the device, we are going to put a banner on there, a message of the day, a banner that says, "Abandon hope, all ye who enter here," or "Unauthorized access not allowed," or whatever your legal department says. We will have fun. In here, I want you to be silly. I want to see interesting, creative descriptions and banners. In the real world, you'll do what the legal department says. If you type "welcome" and somebody hacks in and tries to guess your password, and you prosecute them later and you bring them to court and sue them, their successful defense will be, "But you said I could come in. It said welcome," and that has happened. So the banner that you pop up when somebody first touches when you first touch the router, either through the console line or through the remote, this banner will pop up and it will say, "Unauthorized access, prosecuted to the fullest extent of the law, trespassers will be shot," whatever you want to put in there, whatever the legal department says. Now, do any of you think that if somebody reads that, they're going to go, "Oh my, I better not go there. I shouldn't hack in because it's not legal"? Okay, that's not going to stop anybody. But if you find who they are and you do some forensics and they steal stuff, you bring them to court, then you've done due diligence in a court of law that you can continue the prosecution or whatever, suing them in civil court or whatever it is that you're doing. Okay? So the commands for all that appear here, but this is what we're doing. You get the idea of what we want to do? There's a lot of ways in. We're going to put a password on all those ways in, and we're going to tell people they shouldn't come in here unless they're authorized to do so. So that's the next set of commands, and there's an activity in the lab for doing all of that stuff. And part of the idea in the class is, it's like we have you do a few little things, and we put it all together at the end of the chapter, and you do all of it at once. So I'm just going to have you do all of it at once. We'll see how that goes for you today, because I want to give you at least the last hour to do this lab at the end and play. There's all the commands. So we're up at the top. See the caret sign? I type in enable, and now I'm at the privileged user sign, nothing else. Then I type config terminal or config T. I'm just kind of walking you through this. And then you type enable secret class. Okay, this is a little confusing. For those of you who are English majors, enable could be a verb or a noun. In this case, enable is the command. Enable also means like turn the thing on. Enable it. Right? So it's a little confusing, but in this case, what we're doing is we're putting a secret password on the enable command. And that secret password is, up at the screen, class. Case sensitive. Yes. Now, in this course, we're going to use the highly effective passwords, class, and Cisco. Nobody's ever going to guess those. Never use those in the real world. So everything we do is going to have those two passwords. That way, if you do something on a machine, you put the machine away and you didn't clean it up before you put it back, because again, your mom's not coming to class to clean up after you. So you have to put everything away. And that means erasing everything that you've done on the machines before you put them back so somebody else can start from scratch. But it always happens. Somebody will forget to do it, get into the machine, and now maybe we have a good guess at what the passwords are. Class and enable. Cisco. What class is this? All lowercase. So after a while, you kind of get the sequence of the commands and what they're doing. There is another password setting that just says enable Cisco. That does something different. We're never going to do that. It's for backwards compatibility to old routers that should be smashed or driven over with trucks. Okay? Sledgehammer to those old routers that can't do this command. It has to do with cryptography, It has to do with the processing power of the machine that's able to do a complex encryption scheme. So we are using a fairly complex encryption scheme with this secret password. Enable secret uses complex cryptographic keys. And on some routers, old routers that can't perform that function, we have to use a different password process. We will never do that in here. You may read about it or see it, but it gets confusing. All we will do is the sequence enable secret and then whatever the password is. So I'm telling you this about the secret is because it's a specific kind of cryptography that's being used for the password. Confused? Just follow those commands and all will be well. Enable secret and then the password. Secret is not the password. Secret is giving us a complicated cryptography. That's why there's like this extra word in here. There's nothing about password. It's enable secret.
What was the difference between the fifth class
Oh, look at that. They screwed up. They screwed up. If you want 10 extra cents, send Cisco a note. They have a bounty. No, they don't. Yeah, it's brand new. Cap. That's a capital. That's not. So what is this, 2222? That's my note to myself. Okay, good catch. So this is how you configure it. So this is why you want to read the course and the material. I'm not going to play these videos. You're going to do all this stuff if you want to see how to do it. But you're going to do it. It's not a big deal. Now, you've worked really hard at configuring your router. Would you like to save what you've done? Yeah, just in case there's a power cycle or something. So all the work that you're doing is all the changes you're making to the router or the switch, it's being saved in RAM in the running configuration. So the running configuration file, it's a text file, it's stored in RAM. We would like it to be more permanent. So if I turn off the router and turn it back on again, all my work is there. Because you're not always going to be in class. You're going to want it to stick on the machine. So we want to save that to NVRAM. And in NVRAM, non-volatile RAM, there is a file called start, or the startup configuration. So you have the running configuration, which is what the thing is doing, and it's in RAM. We have the startup configuration, and what do you think happens to that when the machine starts up? Well, we load the operating system. There's a bunch of steps, but we load the operating system, and the router or the switch says, I got this great operating system. I'm all dressed up, ready to go. Where's my configuration file? Give me something to do. And it looks for the startup configuration file. And it could be in some different places, but it's stored for us in NVRAM. So it will grab it from NVRAM, and what's it going to do with it? Any guesses? It's going to load it, and it will be in RAM. Because everything that's running on your computer is run from RAM. The operating system's in Flash, and it's going to RAM. Because everything that's running has got to be quickly accessible, and everything's in RAM. So the operating system, when it boots, it goes from NVRAM, and it's copied into RAM. And then programs run, and it says, where's my config file? And it's, oh, it's over in the startup. And it grabs it in the startup, and it puts it into RAM. And now we have a running config file. That's exactly the same as the startup config file, because all we did was copy it from startup or from NVRAM, and we put it into RAM, and now it's the running config. So you go, shoot, I want to change the name of the router, or I want to change the IP address, or I want to, whatever you want to do. You're doing all that stuff and you make all those changes. Where are those changes made? RAM and which configuration file? The running. And before you go home at night, you want to take what's in the running and put it into the NVRAM or the startup. So what we say is copy, run, start. Or if you want to do the whole thing, you want to practice your keyboarding, copy running -config space startup config. Write this down, commit it to memory, not that, what I'm about to say. Or look at me for a minute so you get it. And then write it down, staple it to your eyeballs, whatever you want to do. Copy, source, destination. That's it. That's the order. Just like DOS. Okay. Copy, source, destination. I'm serious, remember this, because we will move things all over the place. We can go copy, start, run, copy, start, copy, run, start. What's the difference? So copy, start, run means I'm taking what's in the startup config and putting it into the running config. Copy, run, start means I'm taking. So it's easy to get confused because we will have lots of files and lots of places to put them. So copy, run, start's the most common thing that we will do. But when we start storing our files elsewhere, because if it's only on the router, and remember the guy in San Francisco who, right? We would like to have copies of those configuration files elsewhere besides on your computer, or maybe we want them on your computer, they're in a vault someplace, or we have backups. So we need to take it from the running config or the starting config to someplace else. And we do that with TFTP or FTP or secure copy. And so we say copy start TFTP. And if it's out someplace on a server and we want to bring it to the router, we say copy TFTP start, or copy run TFTP, or copy TFTP start, or copy TFTP run. It's all kind of confused, right? What are we doing? Copy source, copy TFTP. Okay, it's out there someplace. Run, and I'm going to put it to the running configuration, bringing it into the router. If I say copy run TFTP, what are we doing? It's running is being saved someplace else. You will do this a lot, but I want you to remember copy, source, destination. Right? What's my source file and where is it going? Make sense? Copy, source, destination. That will get you out of a lot of trouble and save you grief. And make sure it's just like DOS, like Muhammad said. Yeah, exactly. So that's how we save this stuff. Lovely. If you're gonna, anytime you are changing in the router, you're changing the running configuration, if you want to save those changes to NVRAM, copy, run, start. Boom, you're done. I'll tell you about a silly joke one of these days about saving files. Now, would you like a text document of all the work that you've done? Maybe your instructor would like you to send him the configuration files that you've been working on as a text file. How would you send them to him? You're going to take it out of the router or the switch, save the commands as a text file, and just name it muhammadrouter1.txt, emmarouter2.txt. Voila. I'll show you how to do this in NetLab. In Packet Tracer, you'll just send me the whole file. I don't want the configs. You're just going to send me the whole file that you've worked on. So like when we open up that last Packet Tracer file, you're going to go save as your last name and then whatever packet tracer it is, 4.2.6.9, and then send it to me, and I'll show you how to send it. It's pretty easy. So let's look at how we grab a text file. All of those terminal emulation programs, remember those? PuTTY, TerraTerm, they all have a way of capturing text. Now everything that I'm talking about, there are like cookbook instructions in the labs to walk you through how to do all of these things. So I'm just kind of talking to you so that when you do the lab you go, oh, that's what he meant. I'm not expecting you to memorize all this stuff. I'm like telling you a story here. So all the terminal emulation programs have a way of grabbing the text. So here's how you do it with PuTTY. Capture the file here. If I capture the flag, capture the file. So it just walks through and it tells you how to do it. And what else are we doing here? Packet tracer configuration, internal switch settings. Can I keep going? Do you need like a 12-second break to do some headstands? Brains, stand up for a sec. I'm talking. Does everybody stand up? Okay, right. Just kind of move around a little bit, move the shoulders. I can do a little this, do that, most of the stuff around. We'll get to do brain gym after. Okay, you could, what can we do? If you really want, if you want a really good break, put your right foot in, put your right foot out, and do the hokey pokey. Left hand, right foot. Do this. Okay, it's a good thing to do. Everybody's going to do it. Get the hands and there you go. Right, we're doing this. Just kind of pretty hard, huh? Okay, that's enough. Little brain gym. What you're doing is crossing the midline of your body, so you get in the right and the left halves of your brain to sort of like work a little bit better together. That's why I asked if anybody juggles. Like you juggle behind your back, that's really good to do. There'll be a class on that. Okay, so we just talked about how to secure or lock down the router a little bit with our passwords. Question?
Maybe I should.
Okay. We secured the router. We saved our files, right, on an NVRAM, and we got a copy of it, hard copy. And now we're going to talk about IP addresses a little bit. So IP addresses are what make the internet go round. Everything on the internet in a network has an IP address, Internet Protocol Address. You're going to know everything about IP addresses and more. So IPv4 addresses have 32 bits. Remember our exercise earlier? What did we stop at? How many bits did we look at? In the nibble? How many bits are in the nibble? 8. 8. Was it 4? No, that's a byte. Yeah, sorry. Okay. Thank you. So we had 4 bits in a nibble. An IP version 4 address has 32 bits in it, 32 ones and zeros. It's a lot, hard to keep track of. And we write it in a different way. We take those, we break it into 8 pieces. We break it into 4 pieces. I don't know why you guys have a hard time learning this. So we break it into 4 pieces. So if I divide 32 by 4, I get 8. So we create 4 octets. 8 is an octet, right? Mendelssohn wrote a great octet. So there's 2 violins, 2 violas, 2 cellos, and 2 something else. 4 violins, 2 cellos, and 2 8. Octet 8. We take those 8 bits in binary, we convert it to decimal. You saw how to take 4 bits and to convert it into decimal, right? So we'll get to the 8 bits after a while when you're grown up, and then you're ready for, you're okay with 4, we got to get you to 8. Those 8 bits that get turned into a decimal number have a dot in between them. So we call the way we write IPv4 addresses as dotted decimal. We take the 32 bits, we turn them into decimal numbers, and we put a dot in between them. But that's why they look like things like 192.168, 1.10. That sound familiar to any of you? At home, 192.168, like you know those numbers. Okay, and then 255.255.0. You know those numbers, but what the heck do they mean? We'll get there. So we have to put those addresses and those subnet masks onto the devices, onto the routers and onto the switches. Now, I don't know why they're doing this, but so we got all these interfaces, right? There's copper and fiber and wireless. So all of these interfaces that are connecting to something need an address. Your computer has one IP address that it's using for the Ethernet connection. That's all you get. If you unplug the Ethernet and you use wireless, then your Ethernet port is disabled and your wireless port is enabled, and it gets the one IP address. So we only do one of those things at a time. So interfaces get addresses. Your computers have addresses. How many of you configure the IP address on your computer every time it boots up? Like nobody, because it does it automatically through a system called, excellent, DHCP, which stands for Dynamic Host Configuration Protocol. And there's a way to set that up. So your machine wakes up and says, oh, I need an IP address, and broadcasts it out. And a DHCP server says, got one for you, thanks a lot, great, I'm going to use this address. And life goes on. So if you know how to do it, great. If you don't know how to do it, you'll learn. So we configure them on the NIC. Anybody see that? Everybody's seen this before? So when you do it dynamically, notice up here it says the top button, radio button says obtain an IP address automatically. That's DHCP. And you click on the button below, you have to fill all those numbers in. You will do that a lot because you're going to create your own networks, and your networks are going to have specific IP addresses for your hosts and for the intermediate devices for the routers and the switches. So everything that talks on the internet or on a network needs an IP address. That's how you do the PCs. A lot of you may have seen this. If not, we'll do a bunch in class. Okay? Now the deal is you got to click on OK when you're done and close things out in order for the address to stick. So when you open up this dialog box, you got to say OK, OK, OK for it to close. Here's your word for today. Once you've done that, then the address is bound to the NIC. Okay, we bind the address to the NIC. It's the term that's used. So there's the automatic. Okay, now for the annoying part for me. Kind of just relax at this point. I'm going to tell you a story. So once upon a time, there were routers, and routers connected networks together. And routers use IP addresses, and they find IP addresses on the internet. But routers actually don't find IP addresses. They just find the network part of an IP address. And soon you'll learn to tell the difference between the network part and the host part of an address. It's kind of like 680 Mountain View Drive is your host address, and Petaluma, California is the network address. 15 Main Street is your host address, and My City, USA is the network address. Get it? There's these two parts. So the host is your specific machine, and the network is the network in which your host lives. So I can have lots of the same host addresses. I can have 15 Main Street, I can have 15 3rd Street, I can have 15 Park Avenue. No, those are all different because of Park Avenue. I can have all those street addresses in San Francisco, Des Moines, and Seattle, because the host address is in a unique or a different network. Kind of okay? We've got a host address and a network address. Now, routers, back to our story, keep track of networks. So your address has a host part and a network part, but the routers only care about the host parts of the addresses. Sorry, the network parts of the addresses. Right? Routers look for networks. They keep track of networks. In your address, there's the network part and the host part. So the router just looks for the network part, and then it sends traffic to you. Now, in your network, there is a router with one interface that connects to your network, and another interface on the router that could connect to another network. This router's actually got 4 interfaces on it that can connect to different networks. 2 of them are Ethernet, and 2 of them are these other little cables that are for serial connections. We use them usually to connect to other routers, but each one of these interfaces goes to a different network. So here's something to remember, boys and girls. Every interface on a router connects a unique network, a different network. So every interface on a router, except for the console and the aux, connects and defines and creates a separate network or a separate subnet into the same. Yeah.
So if you connect 2 computers to your router with Ethernet, they're on different networks?
At home, you're connecting to a mini God box. You're connecting to the switch. Because those little boxes are routers, switches, wireless access points, firewalls, anything else? A modem, yes. 5-in-1 for $50. Plastic, not a lot of it, and they melt. But what you've connected to is the switch. And the switch is in one network, and the modem side is another network. So the modem side is the public network, and the switch side is the private network. So the router has created 2 networks. One is on the switch side, and the other is on the modem side. So both PCs are plugged into the switch. So what I was about to tell us, get to in our story, it's our bedtime story, is that, well, did you hand me that red cable up there on the rack? Salmon. Okay. And you're going to stand up here with me. Plug one end into one of those yellow ports. Okay, that's my network now. I'm going to put an IP address on that interface, FA01. When I put an IP address on there and turn the interface on, everything that goes out this red cable will go to the network that's been defined by that port and that address and subnet mask. Now, my lovely assistant will plug that cable into another port, any port, pick a port, any port, on the switch. Now, without doing any configuration on this switch, I can plug 23 more PCs into the switch. Would you verify that, please? Yes. There's a number on there. 24, we use one. So, and then there's these 2 uplink ports that are gigabits. So, every PC that I plug into this switch is connected back to the network. They're all in the same network. Now the router keeps track. My router is going to talk to your router and other routers. Would you hold that for me, please? Thank you. So I could have another router, another network to another switch going off of the other port on this router. And the router says, oh, if it's in network 1, it goes this way. If it's in network 2, it goes that way. Everybody kind of okay so far? Now, once I go out this interface, it goes to the switch. The switch's job is to figure out which port you live off of. This is where we get to the host part of the address. So the router takes the whole IPv4 32-bit address, figures out the network part, and it sends it to the right network. So the router gets you to the network. The switch gets you to your host. You okay? Thinking, processing. Need some more RAM? Need a quad core? Need a little more CPU? Yeah, it's a lot. Routers are a layer 3 device. That will mean more to you soon. Switches are a layer 2 device. Layer 3 devices use IP addresses to figure things out. Switches at layer 2 use MAC addresses. Don't worry. A MAC address is unique to each NIC, so the switch keeps track of the MAC addresses. So it knows what every MAC address out of each one of these ports is. So, and this story goes on and on. But the point I want to make is that switches forward frames. That means they go in and out these interfaces. And they only look at MAC addresses. The day job of a switch is to just look at MAC addresses and figure out where they're coming from and where they're going to. A router's main job, routers do both MAC addresses and IP, but a router's job mostly is to do IP addresses. Now, what is this? A router, and it's a type of a computer. This is a switch, and it is a type of a computer. If I want to remotely access the switch through Telnet, I need what to get to the switch? I need an IP address on the switch. Do switches deal with IP addresses? No, they do MAC addresses. Again, their day job is to deal with MAC addresses, but their super secret hero identity is a computer, and if you want to talk to the computer, it needs an IP address. So the switch itself, as a computer, gets an IP address. And then we can remotely access it and control it. But everybody goes, but switches don't do IP addresses. They don't know how to read them. Correct, for their day job. But you can talk to it because it's a computer. And if you want to talk to a remote computer, the computer needs an IP address. Now, you might ask, well, which NIC is the IP address on here? These are not NICs. On a switch, they're not a NIC. A network interface card is NIC. It's an RJ45, but on these switches, it's not a NIC. I can't... For now, I can't assign an... Am I recording? Yeah. You can't assign an IP address to all of these interfaces. Okay? It's not a NIC. So a NIC, remember when we opened up the window that has the Windows properties for configuring the IP address? And if you've seen like a NIC that you add onto your computer, right? Those cards that you used to put in. Okay, that's a hardware component, and that hardware component has software on it. So the NIC talks to the motherboard, and the NIC has drivers, so it can read protocols. These connections don't have that functionality. These are not NICs. You can't assign IP addresses to these physical devices, to these physical 24 ports, because they're not a NIC. They don't have drivers to support IP protocols. Is that enough? Could you disconnect it for me, please? Both sides, and put the salmon cable back. Thank you. Would you maybe have a round of applause for our assistant? Thank you. So, I went through all of that because of this slide. So if your brains are starting to frazzle, that's okay. There's a lot of stuff. We're about to go into a virtual world now. And this is still our bedtime story. So remember all those physical connections we just did on the switch, all 24 of those? I cannot physically assign an IP address to any of those interfaces. But I still need to put an IP address on the switch so I can remotely control it. So where do I put the address? On a router, it's easy. On a computer, it's easy. It goes to your NIC. It goes to one of the interfaces on the router. I go to the interface and I say, your address is thus, and it is so. For a switch, it's, where is it? Well, we have what's called a switched virtual interface, an SVI, switched virtual interface. So we go to the switched virtual interface and give it an IP address. Okay, that was a whole lot for this one slide. It's a little annoying, and I'm a little annoyed that they put it here, but it's the way it is. So this is the magic way that we put an IP address onto the computer that is a switch. We'll do this like for a long time. So this isn't your one shot at this. If you don't remember it, if you don't understand it all, we come back and we go over it again. It'll make sense eventually. There's a lot of stuff going on here. But trust me, it will work. Just like, So that was a deep explanation about why we're going to do the commands that are done in here. So notice, I mean, I don't care if you don't know what VLANs are or if you even understood the SVIs. Main thing is, switch, those ports are not NICs. We need a way to give an address to a switch, so we do it through a virtual interface. Is that enough? Okay, that's the thumbnail sketch. If you've got that, good. And here's the commands to do it. And at this point, it doesn't matter if you don't know what VLANs are. Right? So the first thing I do is I go to the switch and I say interface VLAN 1. What's a VLAN? Later. Notice I'm now configuring the interface. Then I say IP address. And I give it the address, space, and then that 255 stuff, that's the subnet mask. So I've just given VLAN 1 an IP address and a subnet mask. I say no shutdown. What the heck's that? All of your interfaces on the routers and switches are shut down by default. Why? So you plug something in, all of a sudden it's routing. Not a good idea. Everything's shut down until you consciously turn it on. Okay, so you have to say, yes, I want you to route out this interface now. So you have to, so shutdown is the command to shut down an interface, duh. Any of you have 2-year-olds? Any of you ever been 2-year-old? Do you know what 2-year-olds say? A lot. No, 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 okay? So, it's the 2-year-old rule. You undo something by putting no in front of it. So if shutdown shuts down an interface, how do you bring up the interface? No shutdown. It's not unshut down or shut up or, you know. So you undo a lot of commands by just putting no in front of it. Okay, our 2-year-old rule. No shutdown brings up the interface, and then look at that. It says interface VLAN 1 change state to up. We did it. We put an address on the switch. Now we can remotely access it.
The switches always use VLAN 1 for
I ain't going there. Well, I'm talking about this. Later. No, they don't. The IP address with the VLAN with the IP address is called the management VLAN. And we'll leave it at that. Okay, wait for the switch stuff. once things are connected together, it would be nice to know if they work. So one of the ways we check is to ping. Pinging, I've heard of ping before, from submarines, right? Pinging the thing, right? So once we're connected and all the interfaces are up, I should be able to ping you. So I ping 192.168.1.10. It's called an echo request. And you respond with an echo reply. Are you home? Yeah, I'm home. So it's one quick way to see, one, if our connections are good, and two, if all of our addresses are correct. So that's our connectivity check, or our connectivity test. That's what's going on here. That's the ping. So what we're going to do is open up Packet Tracer, the one that's following here, and it's going to have you go through and build a simple network. 2, 3, 3, 3, 3. What's 2, 3, 3, 4? Which one? Are you breaking things? What are you doing? Oh, well, alas. That one. So on page 2412, that's everything we've talked about. So if you open up the PKA, again, if we click on the instructions, that's well, let's do it. That's the PDF of the instructions. And here's the Packet Tracer activity. Appears down at the bottom of my screen. Come here. I open it up. Can cancel this out. Again, underneath here are the same instructions. So you can go either way, whichever is easiest for you to toggle between. 0 out of 90 is what we're starting with. They've put the network on here, so I have 2 switches connected together and 2 PCs. So you will put addresses on interfaces. You'll bring up the interfaces and ping between the PCs. See how those lights were orange and now they're green? It's magic. So we'll get to that, why it was that way. So this is pre-built. You go in here, follow the instructions. So the rest of the class is just going through these steps. You're not going to turn this one in. I want you familiar with the Packet Tracer environment, launching the thing, using it, checking your work as you go so that those numbers on the bottom go from up to 90 out of 90. Make sure you get all the steps. Because labs that we do will entail doing this stuff and more. So be comfortable and familiar with the Packet Tracer environment. And next class maybe we'll grab some gear and do similar stuff with the real equipment. That's going to take quite a bit longer just because moving it around is just chaos. So we'll just do Packet Tracer for the rest of the class. Start seeing some of the commands because they tells you exactly what to do and how to do it. Bless you. And that gets you started in the whole process. Okay? If you have questions, look over the person on your left or your right. Look like they're past you and you don't know how they got there, ask them. Or ask me. I'm going to stop talking and stop recording. And if you need to take a break, you're welcome to do that. And thus endeth the lesson.